Hi, once again with a new video. I'm Viraj and this is my YouTube channel Maths by Viraj. This is the second video I'm uploading under Circle Theorem. In case you missed my first tutorial, you can use the link over here and get to see it. Or else in the description below you'll find the link to my previous videos under Circle Theorem. In the last video, I taught you all the very basics of circle theorem. Now, I am going to teach you all angles of the same segment are equal. Angle at the center is twice the angle at the circumference, or twice angle theorem. Angle at the semicircle is 90 degrees and the opposite angles of a cyclic quadrilateral add up to 180. Angles of the same segment are equal. Right. What does this mean? Now, we should know that if we draw a straight line through the center touching 2 points of the circle, its diameter, or if it does not go through the center, we mark it as AB. This is known as the chord. This chord divides the circle into two parts, the major segment and the minor segment. There we come across the word segment. Let's look at this. If I drew triangles, doesn't matter how many triangles we draw, the angle produced at the circumference by this chord, they all are equal, because we know that these angles, angle ACB is equal to angle ADB is equal to angle AEB, because all of these angles fall under the same segment. Now let's draw the same chord. Now I'm drawing the angles. Now let's mark them as, I can now say that angle AFB is equal to angle AGB. Let's mark them as Y. Now, these two angles are equal in value, and these three angles are equal in value. Don't get the wrong idea that these angles are equal in value. No, they are not, because these two angles fall under a different segment. They fall under the minor segment. These three angles fall under the major segment. Anyhow, bottom line is, you should understand the theory that angles of the same segment, they are equal. Twice angle theorem, or angle at the center is twice the angle at the circumference. These letters theta and alpha are just used for explanation purposes only. Now let's look at the diagram. You see that the angle here and the angle here, they are different. My objective is to teach you all that even though this angle or this angle they change, the theory remains the same. Let's look at this. Here, and we can say that angle AOB is twice the angle ACB. Also, the angle AOB is twice the angle ACB. I have stretched the radius a bit up. From here, I've stretched it up. Now, in the next example that I'm going to take, you will clearly understand that there's a difference between twice angle theorem and opposite angles of cyclic quadrilateral add up to 180, that those two are completely two different theorems. Right. Now, at a glance, by looking at my third diagram, you will see that this is more like a cyclic quadrilateral. That is, a quadrilateral within a circle. But don't misunderstand, here the theorem stays the same. Like in here the angle at the center is twice the angle at the circumference. Similarly, the angle at the center is twice the angle at the circumference. That is, angle AOB is twice the angle ACB. Just like in here, what is it? Angle AOB is twice the angle ACB. The only difference that between these two diagrams are that these two radii, they have just moved themselves up and it is connected at C. Those are the only differences between these two, but the theorem stays the same. Let's try to understand what the angle of the semicircle is 90 degrees theorem is. Now let's look at this. Now these two are just simple circles. How am I supposed to break this circle into a semicircle? Very simple. We just have to draw a diameter across it. What is it? A diameter across it. This is the center. When a chord is drawn through the center, touching 2 points of the circle, remember from the previous video, we know that it is the diameter. Now, if I connected at a single point, if I connected these 2 points at a single point, this particular angle is 90 degrees. Actually, this can also fall under twice angle theorem. Let's try to understand how angle at the semicircle is equal to angle at the center is twice the angle at the circumference theory. Now let's see. These two angles, if this is x, we say that this is 2x. What if I made them straight? If I made them straight, it would look something like this, which means we know that angles on a straight line, they add up to 180. Therefore, this angle becomes 180 and this is 90. So it is also similar to twice angle theorem. What is it? Angle at the center is twice the angle at the circumference. 180 is twice of that of 90. Or as a different theory, it comes as angle at the semicircle is 90 degrees. So maths is really easy. Now you see that these theorems are interconnected to each other. It's very easy. Once again, angle at the center is twice the angle at the circumference is also equal to angle at the semicircle is 90 degrees. Opposite angles of a cyclic quadrilateral add up to 180. Now let's look at this. Now this is a quadrilateral. A quadrilateral is a four-sided figure joined with straight lines. And because it is inside a circle, we call it a cyclic quadrilateral. Now, if I mark these sides as A, B, C and D, I can say that these two angles are opposite, which means I can say that angle BAD plus angle BCD, they add up to 180. If this is P and if this is Q, again I can say that angle ABC plus angle ADC is equal to 180. We know that if it is a four-sided figure, closed figure, that all the interior angles they are up to 360. Similarly, in here, all the angles add up to 360. So what you should remember is the opposite angles of a cyclic quadrilateral, they add up to 180. Today, we learned 4 theorems. What are they? Angles of the same segment are equal. Angle at the center is twice the angle at the circumference, or the twice angle theorem. Angle at the semicircle is 90 degrees and opposite angles of a cyclic quadrilateral add up to 180. There are some mistakes that you children make during the exam. Let's see what those mistakes are. Children, please understand that even though there is no chord present, we can assume that these angles are equal, even though there is no chord present. Because now this chord, we can just have an imaginary chord and we can say that these two angles are equal. Similarly, by drawing a chord here, we can also say that these two angles are equal. Remember, even though a chord is not given in the diagram, you all should know that these fall under the theorem of angles of the same segment are equal. Another small mistake that you all do is when there is a triangle drawn as such, this does not fall under angles at the semicircle is 90 degrees. No, because this does not touch the circumference. Also, you all think that this is not twice angle theorem. No, this is indeed twice angle theorem. If this is x, this is 2x. Just like this. If this is x, this is 2x. Twice angle theorem. Next, again. Now, look at this. 3 points are touching the circumference of the circle, but the fourth is not. Therefore, this is not a cyclic quadrilateral. Or you cannot say that these two angles add up to 180. Or these two angles add up to 180. This does not fall under the opposite angles of the cyclic quadrilateral. Adding up to 180 is not applicable into this. So please understand, don't make these mistakes in exams. Hope you understood today's lesson, and there will be more on the circle theorem. And if there are any things that needs to be clarified, as usual, make a comment below. Don't forget, for more videos, stay tuned and subscribe. Maths by Viraj.